Yes, good morning everyone. A very good morning. Shall we begin the session? Yes, today's topic is structure of a SQL query. That means what is the syntax, what is the example of the SQL query to the SQL queries. Yes, in the last class we have discussed or we have finished with some commands of SQL, that is DDL and the DML, but not we can say exact with the theory, with the syntax, with the example. Today I am going to cover with the each and every step, that is what is the meaning of the create command, what is the syntax of the create command, and what is the example or any one example of the create command. Yes, that is in the SQL. So shall we begin? Okay. Okay. Now let's start with the structure of the SQL query. So there are three clauses or there are three queries. The main queries that is used over here. First is the select, then there is a form, then there are three commands over here or SQL select from input, and the query takes its input. The relations listed in the form place, operators of runtime are specified in the where in the start clause. That means whatever the operators, whatever the scenarios, whatever the column that we are going to use, that is available between the form clause that is used within the select command. And then there is the relation as a result. And we introduce the SQL syntax. So we introduce the SQL syntax, for example, and describe the general structure of the SQL query. Now the query is in a single relation, that means there is a single table that is given and we have to fetch the queries in a single relation. There is a university or query using the university form type. That is find the names of all the instructors. And instructors' names are found in the instructor relation, so we are putting out the relation in the first clause. And the instructor name appears in the name attribute, so we put in the select command that is selected. So select name from instructor, that means select the name or select the attribute that is name from the table instructor. And result is a relation consisting of a single attribute, single relation, single query with the heading name. And if the instructor relation is shown in the figure, this one, then the relation that results from proceeding query that is given over here. Now consider another query that is find the department name of all the instructor, that can be written as select department name from instructor. Since more than one instructor can belong to the department name could appear more than once in instructor relation, and the result of the above query in a relation containing the department names, containing the mathematical operations, containing the mathematical definitions of the relational model also. Therefore, the duplicate tuples would never appear in the relation. In fact, this duplicate elimination is also very time consuming. Therefore, SQL query for SQL also allow the duplication in the result as well as the SQL expression. Therefore, the preceding express query is used for each tuple in which it is appears in the instructor relation. So we are using one of the keyword. That keyword is known as a district. So there is a keyword. So there is a command select the string department name from instructor. That means department name is fetching out or department name field is getting out, but with a distinct value. Distinct value means yes, unique values. From which table? From the instructor table. With the department name, computer science, finance, music, physics, history, physics, computer science, that means it is available over here. Now, yes, when we use the string, computer science is available only once. Finance is available only once, music once, physics once, history once, biology once, electrical engineering. That means there are four, then 5, 6, 7 rows are available over here. And SQL also allows to use the keyword KAA to specify explicitly that duplicates are almost removed. So you select all department name from the instructor. And since duplicate the retention is a default, that means it should not use all in a relation example. To ensure the elimination of the duplicates in the results of our example queries, use a distinct keyword whenever it is necessary. The select statement may also contain arithmetic expression that includes addition, subtraction, division, multiplication. So there are 4 operators that we can also use in the select clause. Yeah, addition, subtraction, division, and the multiplication that operating on the constraint or the attributes or the operators. Yeah, so sorry, not the operator, these are the operators, that's the operands. For example, select ID, name, department name. So these are the 3 fields that is selecting out. And then salary multiplied by 1.1, that is whatever the salary field, whatever salary attribute that is available in the table, that is multiplied by 1.1 and it is displayed over here. Yes. One is the ID, one is the name, one is the department name, one is the salary multiplied by 1.1 from the instructor. And this also returns a relation that is same as the instructor relation except that the attribute salary is multiplied by 1.1. And this shows that what would result if we give a 10% raise to each instructor. That means we does not take the result in any of the change of the instructor relation. So we use various forms of data types that also allow the arithmetic functions to operate on these types, and that is used. Yeah, where clause also allows to select only those rows in the relation that is specified or specified predicate or that satisfy a specified predicate. For example, consider the query. Find the names of all the instructors. That means there is no string, there is nothing. So we have to find all the distinct, we have to find all the queries. Yes, all the instructors in the computer science department who are salary greater than 70,000. So the query can be written as select name from instructor where the department name equals to computer science and the and salary is greater than 70,000. That means department name is computer science and the salary is greater than 70,000. Yes. And if the instructor relation is shown over here, then the relation that results from a preceding query is available. And that also used with the logical connectives and or and not in the where used. And operands of the logical connectivities can be expressed or can be expressions involving the comparison operators. That is less than equals to, greater than equals to, greater than, and double equals to. And SQL also allows us to use these comparison operators to compare the string also, arithmetic expressions, as well as the special types such as the date types. Yes, that means we can use the date, we can use arithmetic operators, we can use the strings. Now this is till now we have discussed about the queries on a single relation. Now next is queries on a multiple relation. That means we have to join two queries, we have to join two relations. There is a queries on the multiple relations, more than one relation. So as far as our example queries are one of a single relation, now there is a need for the queries to run on a multiple relations. So we now study how to write such queries. Suppose one of the best example is that we have to retrieve the names of all the instructors along with their department name and the department building. How these two tables are related? Because the names of the instructors are available in the instructor table. The department name, department building name is available in the department table. So we are considering the two relations, right? Got my point? Yeah, we are considering the two relations, two tables, one is the instructors, one is the department. We are getting out the instructor's name from the instructor table, we are getting out the department name and the department building from the department building name from the department tables. And looking at the schema of the relation instructor, we realize that we can get the department name from the attribute department name, but the department building name is present in the attribute building of the relation department. To answer the query, each tuple in the instructor relation must be matched with the tuple in the department relation whose department name value matches the department name value of the instructor. So in order to answer the query, we list the relations that need to be accessed in the from clause and also specify the matching conditions in the where clause. From and the where are used for the specifying the matching conditions. This is another example, that is select the name instructor dot department name. Now we are getting the department name from the instructor table. We are specifying by the dot operator. That is select the name instructor dot department name built-in from the instructor and the department, where the instructor dot department name, that means we are getting out the name department name from the instructor, that is equals to the department dot department name. That means where the department name from both the tables are equal, we have to fetch the query, we have to run the query, we have to select the records from that table only. And if the instructor and the department relations are shown over here, so the results of this query will be used for the department name that may occur in both the relations, instructor and the department. And the relation name is used as a prefix in instructor and the department name and the department name. So one field is name, one field is department name, one field is building. Now let's see what is the role of each and every clause. First one is a select clause that is used to list the attribute desired in the result of a query. So whatever the attribute, whatever the given data, whatever the given fields, whatever the given relation that is desired in the relation of a query. And the from clause is the list of the relation to be accessed in the evaluation of the query. So one is the select, one is the from, one is the where. A typical SQL query has a form: select A1, A2, then AN from R1, R2 till Rn, where the P is a predicate, P is a condition, where AI represents an attribute and Ri represents a relation. And if the where clause is omitted, then predicate P is also true. Now, although the clauses must be written in the order select, from, where, the easiest way to understand the relation that is specified, or the operations that is specified by the query, to consider the clauses in the operation order. That is first from, then where, then select. And the from clause by itself, it defines a Cartesian product. That means Cartesian product means whatever the scenarios, whatever the data that is relations that is listed in the clause, that is defined formally in the set of the set theory, and in perhaps best derived as an interactive process that generates a tuple from the relation or the result relation from the from clause. And for each tuple T1 in a relation R1, for each tuple T2 in a relation R2, for each tuple Tm in the relation Rn, that concatenate with the T1, T2, Tm into a single tuple T, that add the T into the result relation. And the result relation has the following attributes from all the relations in the from clause, and since the same attribute, same relation will be used, so that is a PL in both the Ri, Rj, as we saw earlier, we prefix the names of the relation from which the attribute originally came before the attribute name. For example, when you talk about the relation schema for the Cartesian product of the relation instructors and the teachers, that is the instructor.id, instructor.name, instructor.department name, instructor.salary, teacher.id, then teachers.course ID. If you see that four fields, ID, name, department name, and the salary, that is from the instructor table. Then ID, course ID, section ID, semester, year, that is from the teachers table. So five fields from the one table, four fields from one table. Right. So there are two tables that is used over here. One is the instructor, one is the teachers. And with this schema, we can differentiate the instructor ID from the teacher's ID. And for those attributes that appears in only the one of the two schemas, we shall usually drop the relation name prefix. The simplification does not lead to any ambiguity. We can then write the schemas as instructor.id, name, department name, salary, then teachers.id, course ID, section ID. That means we are using only one time with the instructor with the dot operator. The next time again we are using the dot, not with each and every one, but only one time it is used. So to illustrate, consider the following relation instructor in figure this one and teachers the relation in figure 2.7. The Cartesian product is that we are taking out the one from one. That means one field from one table, another field from another table. So Cartesian product by itself combines the tuples from the instructor and teachers that are unrelated with each other. So each tuple in the instructor is combined with the every tuple in the teacher. Yeah, yeah, even though it refers to a different instructor, but it is used with the two attributes. So it is used with the dot operator, it is used with the next operator. And each tuple in the instructor is combined with every tuple in the teachers, even those that refers to a different instructor, and the result can be extremely large relation and is rarely makes sense to create a Cartesian. Yeah, so sorry for the disturbance. So let's start again. So one is the ID, that is the instructor.id, the name, department name, salary, teachers.id, course ID, section ID, semester, and the year. There are four fields over here, then there are five fields over here for that from the teachers relation. So first one is the ID, that is 10101, then Srinivasan, department name is salary is 95,000. Then again there is the ID for the teachers, that is the teachers.id, then course ID, section ID, first and the year. So instructor ID, name, department name, salary, these are the four fields. Then ID, course ID, section ID, semester year, these are the five fields. Then 12121, WU for 695,000. Then 10101, it will give the next part. Then CS 101, then 4. Then next ID, that is 2009. Now, this is the next ID, that is 12121 and 15151 and 5 times 2. So instead, we are using the predicate in the where clause that is used to restrict the combinations created by the Cartesian product to those that are meaningful for the desired answer. The field that is common for each and every one, that is instructors as well as the teachers. So that, yeah, this is used to match both the values. Both are the primary key for each and every relation. We don't say that this is the primary key for one of the relation. This is one of the examples. Select the name. Yeah, select name, course ID from instructors, teaching, whether instructor.id equals to teachers.id. And the same thing that I'm going to, yeah, that I've told you is right now. That means ID of both is same for each and every one. Same in the sense that is common for each and every one. And note that the above query output only instructors that would have taught some course, so we have not taught any course that is not the output. And if we wish to output such tuples, we could use an operation that is known as the outage. And in the instructor relation that is shown with the teacher's relation that is shown in this one, then the relation that results from the preceding query that is shown with the code calligraphy Singh, who have not taught any course and do not appear in the above result. And we not only wish to find the instructor names and course identifier for the instructors in the computer science department, but we could add an extra predicate to the workflow. Now what is extra predicate? That is select name, course ID from instructor teaches, where the instructor.id equals to teachers.id and instructor.department name equals to computer science. And since the department name attribute occur only one in the relations, that we can use the department name instead of the instructor or department name in the above query. Now this is the figure, that is a name and the course ID that is available in the two fields. And the result of for all the instructors in the university who have taught the same course, find their names and the course ID of all the courses they have taught. So this generates a Cartesian product of the relation found in the or listed in the from clause and apply the predicate specified in the where clause on the result of the structure. Next is a natural join. Now, there are two types of join. One is the outer join, one is the inner join. Inner join next name is natural join. So in our example query that combines the information from the instructor and the teacher's table, the matching condition required instructor.id that is to be equal to the teacher's.id. And these are the only attributes in the two relations that have the same name. In fact, this is the common case, that is the matching condition is from the from clause. Most often requires all the attributes with the matching names to be equated. And to make the life of an SQL program easier for the common is we can use, or we should use, we can say, with a natural join, or we are going with a natural join that is described below. And in fact, the SQL that supports the various forms, that supports the various material, that also supports with the predicate to join the information from the multiple resources from the multiple data. And this natural join operation also operates on the two relation and also produces the relation as a result. And unlike the Cartesian product of the two relations, which concatenates each tuple of the first two relations with every tuple of the second, natural join considers only those pairs of tuples with the same value on those attributes that appears in the schema of both the relations. So we are going back to the example of the relation instructor and the teachers. Computing instructor natural join teachers, we consider only those pairs of tuples where both the tuple from the instructor and the tuple from the teachers have the same value on the common ID. Common attribute, that is the ID. This is the ID, then there is the name, department name, salary, course ID, section ID, semester and purchase. Select name, course ID from instructor teachers or the instructor.id equals teachers.id. This query can be written more precisely by using the natural join operations. So instead of using the equals to, instead of using the dot operators, we are using the natural join. So select name, course ID from instructor, natural join teacher. That means the instructor and the teachers are joined internally with the field with the course. And both of the above query also generates the same result. And as we saw earlier, the result of the natural join operation is a relation. Conceptually, the instructor's natural join teachers is in the form of the from clause that is replaced over here. That is obtained by evaluating the natural join. And the where and the select clauses are then evaluated on this relation. That are multiple relation combined using the natural joins. So select A1, A2, AN. That means multiple fields from R1, one table, natural join with the R2, next table, the natural join with the R3 and so on till R n number of the tables. And the from clause can be of the form from E1, E2, E1, EA. Select name, title from instructor, natural join teaches course, where teaches the course ID equals to course ID. And the natural join of the instructor and the teacher is first computed as we saw earlier, and the Cartesian product of this result with course is computed from which the where clause respect only those tuples where the course identifier forms a join result that matches the course identifiers from the course relation. This is the query that does not compute the same result. Why? Because we are using the same natural join with the same course. Select name, title from instructor, natural join teaching, natural join course. Next query is select name, title from, when there's a bracket circle, next instructor and the teacher are joined, then join the course using the course ID. So select name, title from instructor, natural join teachers, join course using the course ID. I have a list of the attributes named to be specified. And both inputs must have attributes with the specified names. So consider the operation R1 join R2 using A1 and A2. That is used with the natural join R1 and the R2 with T1.A3 and the T2.A3. Therefore, in the preceding SQL query, the join construct converts the teachers specified name. So let's start with this one. That is select name, title from instructor, natural choice teachers. That means an instructor and the teachers are joined internally. Then both the tables are joined. Then it is joined with the course using the course ID. So this requires a list of the attribute names to be specified, and both the inputs must have attributes with the specified names. So consider the operation R1 joins R2 using A1, A2. That accepts that a pair of the tuples T1 from R1 and T2 from R2 matches if T1, A1, T2, A1 and T1, A2, T2, A2. Both the attributes name that is not required with the T1.A3 equal to T2.A3. Now next part is the additional basic operations. What are the very basic operations? Yeah, that is additional. That means divide, multiply, less than, greater than, logical operators, bitwise operators. So what are the various additional basic operations that is included in the SQL that I'm going to cover within the next class, that is the tomorrow's class. So till now, any doubts anyone? Any doubts regarding the assignments, regarding the modules, so you can clarify the doubts for me.